Hello and welcome to this lesson in our study of linear algebra. Our topic for today is best approximation. So first of all, let's consider the best approximation theorem. When you have a WB a subspace, when you have a WB a subspace, when you have WB a subspace of finite dimension, and YB a vector of also a finite dimension, then y hat is what the orthogonal projection of y onto W, where W is a subspace and is determined by the orthogonal basis of W. Then we say that y is what the closest point in W to y, in the sense that the distance between y and the closest point in W, which is y hat, is less than the distance from y to a vector in a subspace W. Okay, so now best approximation. So you see the y hat, which is the orthogonal projection of y onto U, is called the best approximation to y by elements in W. And distance from y to v given by this can be regarded as the error of using v in place of y. So we have to minimize error. So when we minimize error, we set v to the best approximation, which is y hat, and the error is given by the distance between y and the closest point in W, which is the best approximation. Okay, so this is a typical example. We have our vector u1 to be 2, 5, -1, u2 to be -2, 1, 1, y to be 1, 2, 3, and where W is the span of u1 and u2. Then the closest point in W to y is given by y hat, which is just like expressing y as the linear combination of what u. So y hat is given by y dot u1 dot u1 u1 times this, y dot u2 over u2 dot u2 times u2. Okay, so y dot u1 is given by negative times 1 is -2, 2 times 1 is 2, 3 times 1 is 3. So we have positive 3. Okay, that's -1 plus 2 plus 3, so we get positive 3. Then also find u1 dot u1. u1 dot u1 is given by 2 squared plus 5 squared plus 1 minus 1 squared. Okay, which is 4 plus 25 plus 1, which is 30. Okay, then you can substitute y dot u1 and u1 dot u1 here in this. Okay, then you multiply by vector u1. Then you solve for y dot u2. That's -2 plus 2 plus 3, which is 3. Okay, I'm sorry, y dot u1 is 2, y dot u1 is 2 plus, so 2 plus 10 minus 3. Yeah, so 2 plus 10 minus 3 is 9, and u1 dot u1 is 30. Okay, then y dot u2 is -2, y dot u2, that's the product of u2 and what y, the inner product. So you get -2 plus 2 plus 3, which is 3. Then you solve for u2 dot u2 is given by 4 plus 1 plus 1, which is 6. Then you substitute it here, then you multiply by u2. So when you simplify it, this is what you get. That's -2 over 5, 2 and 1 over 5. Let's look at the second example. We have the distance from y in Rn to a subspace W is defined as the distance from y to the nearest point in W, right? We have to find the distance from y to W, so we have to find distance from y to the nearest point in W. That's y minus y hat. Okay, so first of all, we find y hat. Okay, the y hat is the nearest point in W, okay, or is the same as the best approximation. So, and it's the same as the orthogonal projection of y onto u. Okay, so y hat is given by so you have u1 u2, so y hat is given by y dot u1 dot u1 plus y dot u2 dot u2. Okay, so when you simplify, you get y dot u1 to be 15, u1 dot u1 to be 30, y dot u2 to be negative 21, and u2 dot u2 to be 6. So when you simplify it, you get negative 1, negative 8, 4. Okay, negative 1, negative 8, 4. So therefore, we can find a y minus y hat. We know our y to be negative 1, negative 5, 10. And our y hat to be negative 1, negative 8, 4. So therefore, y minus y hat is given by this. So you have minus 1 minus 1 is 0. Minus 5 minus 8 is minus 5 plus 8, which is 3. Then 10 minus 4 is 6. So we get this 0, 3, 6. Then therefore, the distance from y to the nearest point in W is square root of 0 squared plus 3 squared plus 6 squared. Okay, and you know our 3 squared to be 9. So 0 plus 9 plus 36 is what? Root 45. And we know 45 is the same as 9 times 5. And square root of 9 is 3. So we get 3 root 5 units. Okay, 3 root 5 units. 3 root 5 units. Now let's try our hands on this exercise. We have two questions. First one, we have to find the best approximation to z by the vectors in the form c1 v1 plus c2 v2, where z is given by this, v1 is given by this, and v2 is given by that. Then the second question says that when you have any vector y to be 5, negative 9, 5, u1 to be negative 3, negative 5, 1, and u2 to be minus 3, 2, 1, then you have to find the distance from y to the plane R3 spanned by u1 and u2. So you can pause this video and try your hands on the following questions. Alright, so we have, let's consider the first question. We have to find the best approximation. So we have our z to be this, we have our v1 and our v2. Okay, then the best approximation to z by the vectors in the form c1 v1 plus c2 v2 is given by, so with this is the same as, the best approximation is the same as the orthogonal projection of z onto v. Okay, so we have z hat given by this, that's z dot v1 over v1 dot v1 times v1 plus z dot v2 over v2 dot v2 times v2. Okay, so we solve for z dot v1, that's the inner product of z and v1. So when you simplify this, you get 10. Okay, then v1 dot v1, when you simplify it, that's 15. Z dot v2 gives us negative 7. Then v2 dot v2 gives us 3. Okay, so we can substitute our values into this equation or this formula. Okay, so our z hat is given by z dot v1. Our z dot v1 is given by 10 over v1 dot v1, which is 15, multiplied by v1. Z dot v2 is, we had negative 7, then v2 dot v2 had 3, so we have this one. Okay, so when you simplify, you see 10 over 15 is the same as 2 over 3, because when you divide 2 by 5, you get that. Okay, so we have this. Okay, we have this. So when we multiply the first term by 2 over 3, we get this. When you multiply the second term by negative 7 on 3, we get this. Okay, so when we simplify these two terms, we get negative 1, negative 3, negative 2, and 3. Okay, that is what the best approximation. Okay, now let's move on to the second part of the question. The second question. So we were given y to be 5 minus 9 5, u1 is minus 3 minus 5 1, and u2 to be minus 3 2 1. There we are told to find the distance from y to the plane in R3 spanned by u1 and u2. Okay, so this means that we are to find the distance from y to y hat. Okay, and y hat is the same as orthogonal projection of y onto u, and the difference between y and y hat, that's y minus y hat, is the same as the component of y orthogonal to u. They are the same. Okay, so first of all, we find y hat. So y hat is given by this, that's y dot u1 over u1 dot u1 times u1 plus y dot u2 over u2 dot u2 times u2. So y dot u1, that's inner product of y and u1, we get 35. u1 dot u1 also gives us 35. Y dot u2 gives us 28. Y dot u2 gives us, negative 28. Yeah, negative 28. Then u2 dot u2 gives us 14. Also okay, so we have solved for it, so we can substitute our values there. We had our y dot u1 to be 35 and u1 dot u1 into 35. So when we substitute it into this formula, we get this one. Okay, where negative 28 is what? The inner product of y and u2, and 14 is what? Inner product of u2 and u2. Okay, so when we simplify this, we get y hat to be 3 minus 9 minus 1. Okay, so we can find y minus y hat. So y is what? 5 negative 9 5. Y hat is 3 minus 9 minus 1. When you simplify, you get 206. Then we can find the norm. So the norm is given by the square root of the absolute of 2 squared plus absolute of 0 squared plus absolute of 6 squared. So when you simplify this, you see 2 squared is 4, 0 squared is 0, 6 squared is 36. So you get 36 plus 4, which is square root of 40. But we know 40 is the same as 10 times 4. Okay, and square root of 4 is 2. So we get 2 root 10 units. Thanks for watching this video.